All right. Okay. So, okay. Let's try this for the third time now. Okay. Moving forward. What was the first concept that we had learned? Sorry, what was that? That was in chapter 23, I would agree. But we have to back up to chapter 17, I would presume. Okay, Bohr models is one. And then dot diagrams. So we're going back quite a ways. Yes, your slide rule, which is a type of tool which you can utilize. Yes. Okay. What's going on up there? I'm going to go with no. Okay, so chances are we would want to is something funny? Why don't you put that back there so then you don't have to go through that temptation? All right, let's go for the fourth time now, right? Let's try to get something accomplished today. Okay? So you can, if you have a table, periodic table, maybe that would be a good idea to get that out. Or if you can see the one on the side of the room, that's fine. Okay? Whatever you think is most beneficial for yourself. And upon doing that, if you have found a or your periodic table that was, I want to say, not just given, but issued to you, okay? And that, of course, that's something that you can keep. You can start as simple as you wish, or you could make it as complex as you may wish. So what we mean by that is pick a number off of the periodic table.
47.
47, okay? Which is no coinkydink, likes to wave at gold and say, hey, you. Okay. All right. So silver, Ag, element number what?
47.
Now, this is what you don't need to know, the chemical properties and the physical properties of silver, but why would it be considered as such a valuable metal? Yes, it's considered a precious metal, but it doesn't do things that many other metals do. Does it corrode? No, it doesn't. So one of the things that is probably, how do I want to say this, unique or interesting is that the field trip that we took up to SDSU with some of the, if you want to call it joints and body parts, some of them had titanium fittings on there. And when you hear the metal titanium, what comes to mind? Why would we use titanium joints in surgery for humans? Strong, lightweight, and it also doesn't what? It does not corrode or rust. That's correct. So if that's the case, titanium, element number 22, silver's already up to number 47. Why not use silver instead of titanium? Well, it does weigh more. That's a physical property, but it's too expensive. And as far as the tensile strength, that I really can't comment on. But silver, also good in wiring, although we use copper instead because it also conducts electricity very well. But there again, silver would be just too expensive to utilize. Okay.
What is better though, copper or silver?
I would say silver, but there again, what you actually have for availability and price is something that leaves to be desired. Because if you could run premium gasoline through your tanks all the time, perhaps you would, but we choose not to. Why? Because it's more expensive. Okay? All right. So if we were to do the Bohr model, what number is going inside this circle?
47.
Why would we put 47 inside of there? Sorry? That is the atomic number, which means what?
Things it has atoms.
Well, not only that, you're not totally wrong. It's what it needs to add up to, because what's inside of here? The number of protons, which have what charge?
Positive.
So then what are we going to be putting on the outside here? And that's where what you had said, what you need to add up to 0 is what and you're not wrong when you say that. Okay, do we need the slide rule? Okay, the big number 1 is telling you what?
First column.
The first energy level. Okay, and then how many electrons can the first energy level hold? Okay.
Can we draw the whole slide rule again, quick?
Yeah, so I could write it down on a piece of paper for me.
And if you choose to use a slide rule that you make, what do you suppose can be on that piece of paper? Nothing but the slide rule. Make sense?
What if I put on the back of this?
You know, I would suggest not. You want to know why? Because then you are flipping back and forth. How about a piece of scratch paper? Okay. Now, if you're using notebook paper, that's probably fine, but perhaps a blank sheet of paper would be better. And what we mean by that is the blank side of something that you're not using. This you are using, but if you want to use notebook paper, that's fine. Okay. I'm probably going to run out of room. Does that show up all right? Looks like it.
Down quick.
Sorry, I just saw a really funny something.
All right. And way out here, we'd put 4 something. Yes, 4F. Okay. So again, why is it that we call this the periodic table?
Because you have all the different blocks. S block, B block, B block.
Because when we, how many, it's a funny looking 5, every year, how many days are in May? And last Monday in May is always this holiday. Okay? The second Tuesday in November every year is always what? Just the opposite of Memorial Day would be Veterans Day. Okay? The last Thursday in November is Thanksgiving. These patterns, they continually repeat themselves, don't they? Okay? So they might not be the same numerical day, but the same day of the week is when they appear. That is a periodic function. It's something that continually repeats itself. Do we see something here that repeats itself? Yes. Okay. I don't think we need that 7D there. I think that's where we would stop. Okay, and making this a little bit bigger, okay, would help. And being neat will help too, and drawing straight lines. Although with not having a straight edge, I'm not the best at it either. But if you draw it big like this, these lines don't intersect with one another. Okay. So just like what we would depict, doesn't take any energy for a ball to roll downhill. Okay? So it doesn't flow uphill.
So we go down the line.
You go down the line. That's why it's a slide. Okay? So when we think of, oddly enough, when we talk about geographically speaking, all rivers, the majority of rivers, I should say, probably well over 90% of them, flow what direction? They flow downhill, but can you be more specific than that? Okay, that would be correct if you live in the northern hemisphere.
They would still go south though, wouldn't
They would.
Oh wait, they'd go north if you were in the southern.
If you're in the southern hemisphere, they'd flow north because typically all rivers flow towards what?
Down.
What is it that surrounds the earth? The equator. Are there exceptions to that? Yeah. Oddly enough, I want to say it's up around the Fargo area, North Dakota. The river flows north because it's downhill. Right. Majority of time, all flivers. That's what happens when you combine rivers and flow and say flivers, okay? All rivers flow towards the equator, okay? But that's not always the case. Okay, so here's the big number one, and some of you, if you do this, why would we? I suggested that you don't.
Shows how many
It shows how many columns each of those blocks have. Okay?
You suggest we don't.
I suggest that you don't.
It makes it look sloppy.
And I'm going to tell you why here in just a moment. Okay, so just like what we said, these roll downhill on a slide. You climb up to the top of the next one, and this is telling you something specific. That number.
Shows you what energy level.
Okay, so are we in the first energy level?
Yeah, right
No,
now.
second.
Now you are, but
We're in the second energy level now.
2.
Okay, do we need to climb up on top of another slide?
Yes.
We're at the bottom here, climb up to the top of this one. Do we need to make a new energy level?
No.
Okay, what is this telling you?
it's the
Second energy level,
but it's a different part of the
it's a different block. Okay, and how many can the P block hold?
6.
Okay, so then what is this telling you?
You would make new energy level.
How many?
2.
Okay, then at the bottom of this slide, climb up to the top of the next one. What is that telling you?
6.
Okay, we'll put all 6 of them in there. What is this telling you?
New energy level.
Okay, all right,
We put 2 on that.
okay. Now, this is what happens if you put all these numbers in here. You're going to look at that and say, now we'll come full circle with this. If you do that, oh, well, I'm going to put 10 here. Start using your simple math here.
It goes over.
Okay, we've got 8 and 12 is 20.
We're at 30.
Is that right?
Yeah, no, not yet. We need
No.
to keep going.
Okay, so,
Wait, why?
well, that, I guess that's correct. It's the next, I goofed. Okay, so now we're here. Okay, 4P6 then. I'm going to put all 6 of them in there. Okay, now we do that. Okay, now what happens if you put a 10 in there? You end up with 48.
You do 9.
We want 49?
4D9.
Or
4D9. See, I keep thinking you say 49. 4D9. That's what happens to me if you go by these numbers. It just tells you how many columns they have. Okay? You're not always going to put that number in there. So that's why we would suggest that you don't do that, because the table's telling you the exact same thing, that there's 2 columns here, there's 6 columns over here, there's 10 here, and then 14 down here. Okay. So now, some of the things that we see is, and I'll write on papers that this is not hybridization to where some people will put 10 here, okay, and then put a 1 there. Don't do that. That's what we call hybridization, okay? But that is the stable element.
What do you do if it's 1? Just so it's easy.
Put an E in there so it doesn't blend in with the line. Yep. Then another aspect that we had learned was this.
With the atomic masses.
Well, true.
Oh, it was the where you do it in order.
Mm-hmm.
I don't remember it's called though.
what is it?
You use the noble gases.
Yeah, I don't know how you do. I don't know what.
You just start
Oh god.
So since it's
Right.
silver, we start at bromine.
I don't
We
understand.
start at bromine, which is
Okay. So where are noble gases located?
8th column.
Okay, in the 8th column. So what happens if you go up to 54?
That's too much.
Too much.
That's xenon. That's too big.
You have to use krypton.
So then if you go down to krypton, that number is what? What a coinkydink. There it is. Okay, watch out, Superman. All right. So this could be confusing, but notice we're already up to 36, okay? Which means 36 from 47 is just what?
11.
Okay? So on your table, what period is krypton in? Remember, periods are vertical. Okay? And what block is krypton in?
P6.
Okay, so it's the 6th column. Is that energy level full going all the way across? Okay, so that means 4th period, P block, 6th column. So then what comes after
We start at 5S.
4P6? 5S2 does. Okay? Now we follow our slide rule.
49.
Okay? Because what happens when you add 9 plus 2 plus 36?
47.
Gives you 47, so that's got to be right. Okay? And another aspect that you can do to perhaps see if you are correct, what column in the D block only is silver in? And that's what we got. Not only just here, but also there. Okay? All right. Then probably the only aspect that we would possibly continue with this is if you were to do a dot diagram. This is where it gets to be tricky. Okay? Let's say we're going to do Okay, we already know the symbol for silver is Ag. Okay, now we don't use, how do I want to say this, valence numbers for D block elements, because the majority of them, like for instance cobalt or chromium or nickel, okay, what do the, oops, that's backwards, what do these typically mean? +3, +2, okay? Those are its oxidation states or charges, which means any one of these, if we pick nickel, it can give away how many electrons? It can give away 2, or it can give away 3, okay? This is where you can use your periodic table, because what charge does silver form? Plus what? So that must mean how many electrons does it give away?
1.
Okay? So that means what would we put on here for a diagram?
Plus 1.
Well, you could write +1, but we would just perhaps put an X, a dot, or an E. Okay? Now, chloride being a halogen, or chlorine, it forms a -1 charge. And what column is that in?
7.
So then how many valence electrons does it have?
-1.
That's its charge.
Oh, yeah.
7.
And it wants 8.
1, 2, 3, 4, 5, 6, and 7. This now has 8 around that. Silver does not have any. Is that all right?
Yeah, that's right.
Metals don't want any electrons around them. That's why it went to the chlorine. So when it comes to these predictions, okay, you can say valence numbers for column 1, for column 2, and then columns 3 through 8. You can do that. Do not use predictions for D block elements. You have to go by its charge. Well, then you might ask yourself, well, what happens when you're dealing with one of these D block elements? Go ahead and pick any one of these 3. Okay? So how are those different?
There's 3 close ones.
Right. Okay, go by your negative charge, as we would always say.
It shows the different charges.
If this is -1, and how many do you have?
2.
So this whole side is -2. So this must have a charge of what? +2 to add up to 0.
And the bottom one must have +3.
So then -3, this must have to have a charge of +3. So then you pick which one of those 2 would you want to utilize for a dot diagram? Top or bottom?
Top.
Okay? So this is where you ask yourself, how many valence electrons would nickel have?
2.
Why are you right?
Because there's 2 chlorides.
True,
Everyone's
because it's giving 2 electrons away.
0 people.
All right? Oh, that orange isn't racing very well. Well, you just got to put a little elbow grease into it, I guess. Okay, so then what are we going to put in the middle? Nickel, okay? And how many valence electrons?
2, one on each side. And then chlorides on each side.
So anytime you have these electrons here, when you do this, you are creating an ionic bond because it's a metal and a non-metal. So this one's got 8. You don't have to put these boxes, but you can. And again, nickel doesn't have any because it's a metal. It wants to give its electrons away, just like that of the silver.
No matter which side the nickel goes on or the chloride goes on,
No, because you're going to put one on each side. You can put one on the top and one on the side. It just makes more
You can
sense.
put it on the top or bottom.
You can put,
Okay.
can, but it's just a lot cleaner / neater to make it linear.
Yeah.
All right, I think that's enough for today. So, front row, are we on the bus here?
Yes, sir.
Second row. Third row. Okay, we'll catch up to you next time.